Welcome once again, and in this lecture we are going to solve some question on uh, finding center of mass of discrete system. Okay, in which the masses are not continuous. Okay, the mass distribution is not continuous. Okay, this mass will be distributed discontinuously. Okay, so suppose this is okay, wait, yeah, suppose this is okay, this is y-axis, and this is x-axis. Wait, yeah. This is x-axis, this is y-axis, and here this point is A, this point is A, this is B, this is C, and this is D. And here mass is 1 kg, here mass is 2 kg. Okay, and this mass is this mass is 3 kg, and this mass is 4 kg. Okay, this is D, and this is a square, and this length is A, this length is A, and this length is also A. We have to find center of mass. Okay, so first we have to do practice. Okay, the first thing is we have to find center of mass, and when we find center of mass, then we are able to solve a lot of more questions. Okay, so finding center of mass is very important. Okay, so here we have to find, this is xy plane, so we have to find center of mass is basically a point. Center of mass basically a point which has coordinate. Okay, so we have to find what is the coordinate of that point. Okay, which we call center of mass. Okay, so the x coordinate will be mass. Okay, mass of 1 kg block, into position of 1 kg block, so 1 into 0 x coordinate. Okay, because x coordinate at this point is 0. Okay, now we are going to, okay, and this, what is the x coordinate here is A, x coordinate here is 1 0 A 0. Okay, plus 2A. Okay, plus, okay, now what is the again x coordinate here is A. Okay, x coordinate this is A, so 3A plus, and what is the x coordinate here is 0. Okay, so 4 into 0 divided by, okay, total mass 1 kg plus 2 kg 3 kg plus 3 kg 6 kg plus 4 kg 10 kg. Total mass is 10 kg. Okay, so x coordinate will be, if you look at this carefully, this will be 5A by 10, this will be A by 2. Okay, so we had find what is the x coordinate. Now we are going to find out what is the y coordinate. Okay, so what is the y coordinate here is 1 into position 1 into 0, because y coordinate is 0, plus here what is the mass here, 2 into 0, because y coordinate is 0, plus 3 into A, because here y coordinate is A, and plus 4 coordinate for this point, 4 y coordinate is A, so plus 4A, and divided by 10. Okay, because 1 plus 2 3 6, and plus 4 10. So what we get, 7a by 10. This will be y coordinate. Okay, so and now we are going to find out z coordinate. Okay, so z coordinate will be, you know, what is the z coordinate of each point is, will be z coordinate of each point will be 0. Okay, z of each particle is 0. Okay, so what we get, 1 into 0 plus 2 into 0 plus 3 into 0 plus 4 into 0 divided by 10. This will be 0. Okay, so my what is the position of center of mass? Center of mass position will be a by 2, 7a by 10 and 0. Okay, so center of mass basically is a point whose coordinate is this and this. Okay, so a by 2, so a by 2 will be somewhere here. Okay, and 7a by 10 will be somewhere, this is the midpoint, let's suppose, so it will be somewhere here. So this point will be center of mass. Okay, 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 and okay, and the motion at we can assume that this will be behave as a part, just as a point object. Okay, and we can apply Newton's law on it. Okay, so this will be the center of mass. This point will be center of mass. Okay, these things are very important. Okay, it will create so many problems. Okay, which type of question come in IIT nearly. I forgot about year, in which year such type of question has come. The question is something like this. This is a hinge point, and here this is a mass, and this length is L, this length is L, this length is L, and here this is particle of mass M, this is mass M, this is mass M. So here force F is applied. So question is, here force F is applied. Question is, find what is the force applied by hinged. Okay, guys, and this is the rod, and this is a rod, this is rod, this is a rod, this is a rod. Okay, so and this rod, all the rod are massless. Okay, and the point, and let's suppose this is A, this is B, and this is C, and here a sphere, and here a sphere is kept right here, and one sphere is kept right here, another sphere is kept right here, and they are connected by a massless rod. And a force F is applied as shown in figure. So question is, what is the force applied by this hinge point? Okay, so this question become very is at first look it is very complicated, but when we apply center of mass concept of center of mass, then what we say, that first we have to find what is the position of center of mass. Let's suppose position of center must be somewhere here. Okay, then what we say, that that this center of mass, a force F is applied. Okay, and this mass is hinged from this point, so okay, a force F is applied here. Okay, there are two types of force now, which is force F, and another force is F is applied here. So this is the hinge. Okay, this point is hinged, so here F is applied, so it start rotating. Okay, so by calculation of circular motion, with the help of circular motion, we will determine what should be the force. Okay, so there are various type of question come into the picture. So the first step is find out what is the position of center of mass. Okay, so this is the very important step, and in a big question, it if you make a mistake, and if you could not understand that here you have to find center of mass, then you are not able to solve the question. Okay, so this is the simple, the finding center of mass for discrete particle is simple, but when it come in a big question, then it is very difficult to recognize that you are able to solve this such type of question with the concept of center of mass. Okay, so be aware. Now okay, yeah, it is correct to okay. Now we are going to solve another question. uh, okay, the question is like this. Question is position vector position vector position vector of three particle position vector of three particle position vector of three particle uh, of mass of mass 1 kg 1 kg 2 kg and 3 kg are first r1 is equal to I plus 4j plus k. Okay, r2 is equal to I plus j plus k. Okay, and r3 is equal to 2I minus j minus 2k. Okay, so we have to find what is the position vector of center of mass respectively. Okay, these are the respectively. So we have to find what is the position vector of center of mass. What is the position vector of center of mass? Okay, so let's do it first. So you know what is the RCM? RCM is M summation of MI divided by total M. Okay, so can I write 1 into I plus 4j plus k plus 2 into I plus j plus k plus 3 into 2I minus j minus 2k. Okay, divided by 6. So if you look at this carefully, what we get 1 2 and plus 6, 1 2 plus 6, say it will become 9I by 6 plus 4 plus 2 6 minus 3, that will be 3 3j by 6 plus 1 plus 1 plus 2 3 and minus 6, so minus 3 k by 6. Okay, minus 3k by 6. So if you will look at this carefully, what we get 1 by 2 3I plus j minus k. Okay, so this is the position of this is the coordinate of this is the position vector of center of mass. Okay, so look here, you know, here the center of mass is in 3D space. Okay, here center of mass is in 3D space. Okay, so you know the finding position of center of mass is very important. Okay, very, it is very important, and we should do it. Okay, so now we are going to discuss about center of finding center of mass of continuous objects. Okay, finding center of mass of continuous objects. Okay, okay, okay. You know what is the difference between continuous masses and discrete masses is that, you know, if there is mass, okay, what is the, if you know, if he at this point is a mass, at this point A is a mass, and you know, and at this point there is a mass. So in continuous mass distribution, between them, between point A and B, there must be a mass, there must be mass. Okay, if at this point is a mass and at this point is mass, then between A and B there must be a mass. Okay, and this is called continuous mass distribution. Okay, and you know, and if mass distribution is discontinuous, you know, here is the mass and here is the mass, and between them it is not necessary that there is a there be a mass. Okay, between them it is not necessary that there be a mass. So you know, such things is called discontinuous, and it is called continuous. Okay, it is called continuous here. Okay, here is the mass, here is a mass, non-zero mass, here is a non-zero mass, then between them there must be a mass. So you know, if you know the meaning of integration, what can I say? Let's suppose this is an arbitrary shape. Okay, this is an arbitrary shape, and we have to find out. Okay, this is an arbitrary shape, and we are going to find out the center of mass. Okay, so you know, let's suppose from X, this is a dx element, this is dx. Okay, this is the elemental dx, and you know, its mass is dm, its mass is dm. Okay, at this portion mass is dm. Okay, so what is the coordinate okay, so what is, so this, the center of mass will be something like this. Okay, and similarly, and after some time, and here, and this particle is after some time this particle, so we have to finally add these things. Okay, so this means this is the integration x dx, if you know, and divided by total integration of dm. Okay, x dm divided by integration of dm. So this is called x coordinate of center of mass. Okay, what is the x coordinate center of mass is x dm divided by dx. Okay, and what is the y coordinate? Y dm divided by dm. Okay, what is z coordinate? Okay, So these are the x coordinate, y coordinate, and this and z coordinate, okay, of center of masses. Okay, now we are going to find out the center of mass of simple geometry. Okay, going to find out center of mass of some simple geometry. Okay, so first we will try to find out what should be the center of mass of rod. Okay, in which, okay, so okay, let's suppose this is rod, and here this is rod, and it has uniform mass distribution. This is rod, its mass is m, and this length is l. This mass is m, and this length is l, and mass distribution is uniform. Uniform mass distribution. Uniform mass distribution. Mass distribution. This means and there is uniform mass distribution. Okay, this means that if my length is equal length of the rod has equal masses. If this is dx at this point, so its mass will be same, and if here is the dx, its mass will be again same. Mass here m1 and m2 will be same. Okay, so this is the meaning of uniform, in uniform mass distribution. Okay, in equal interval of length, the mass should be equal. In equal interval of length, the mass should be equal. Okay, so what is the, so let's suppose from this, so let's suppose from this end at a distance x. Okay, let me make another pen. So let's suppose at a distance x from here at a distance x, this is x. Here there is a dx element. There is a dx element. Okay, dx element. So we have to find what is the dm. Okay, so we want to find what is the, okay, what is the mass here. We want to find what is the mass of this elemental portion which is at a distance x from the from the origin. Okay, we want to find out what is the mass. Okay, if I had said that it has uniform mass distribution, so what uniform mass distribution it means, that equal interval of length has equal masses. So this means that m by l should be equal to dm by dx. Okay, because this length, this, okay, dm by dx should be m by l. So what is the dm? M by l dx is equal to dm. Okay, mass distribution is uniform. This means m by l is equal to, so okay, so we find out, we know what is the dx, and so what is the x coordinate. X coordinate is m by l dx x. Okay, this summation, this means integration, this divided by total mass. Total mass is m. So what we get, 1 by l x dx. And what, okay, and from what is the variation of x, we have to check, we have to put the limit. So x varies from here, x varies from x is equal to 0 to x is equal to l. Okay, x varies from x is equal to 0 to x is equal to l. Then this will be 0 to l. Okay, so this will become 1 by l square by 2. So what is the center of mass? Center of mass will be L by 2. Okay, x coordinate of center of mass will be L by 2. Okay, and what is the y coordinate? If you look at this, whole masses are kept along x-axis. Okay, so y coordinate will be, y coordinate of all masses is 0, y coordinate of all the masses is 0. So the y coordinate all the masses is 0. So the what so this means y of center, y coordinate is y dm. Here y is 0, so this becomes 0. Okay, so y coordinate will be 0. So position of, and similarly z coordinate will be 0. So position of the center of mass will be L by 2, 0, 0. This is the position of center of mass of rod. Okay, uniform rod. Okay. Okay. Now we are going to solve another question. A different question is, which is as follows. Okay, the question is, a rod of length L is placed along a x-axis. Okay, let me draw. Okay, this is x-axis, this is x-axis, and this length is L. This length is L. Okay, and this point is 0. This point is 0. Okay, and it is given that linear mass density is linear mass density is a, okay, not give me 1 plus x. Linear mass density is 1 plus x. Okay, or I'm not going to give it 1. Let me give it to 1. Okay, so linear mass density 1 plus x, and this and rod of length is 1. Okay, so we have to find what is the center of mass. Okay, so what is the linear mass density? Linear mass density is basically dm by dx. Linear mass density is basically dm by dx, and this is 1 plus x. Okay, this is the meaning of linear mass density. So in earlier question, this quantity is constant. Okay, dm by dx is constant. So okay, so let's suppose at a distance x from origin, here this is the mass, this is a dx length, this is dx length. Okay, this is a dx length. So what will be, so we have to okay, so what is this mass dm? Okay, so what is this mass dm is, dm is equal to 1 plus x dx. Okay, 1 plus x dx. Okay, and now, so what is the x coordinate of center of mass? X coordinate will be x, okay, x dx. Okay, x dm, x coordinate of center of mass will be x dm divided by integration of dm. Okay, divided by integration of dm. Okay, so what it will be? So this will become, okay, this will become x 1 plus x, because dm is equal to 1 plus x dx. Okay, 1 plus x dx divided by 1 plus x dx. So what is the value of x? We have to put the limit. So x varies from 0 to 1. 0 to 1, 0 to 1. Okay, so if you look at this carefully, it becomes x square by 2 plus x cube by 3 divided by x plus x square by 2. Okay, so what we get? 1 by 2 plus 1 by 3 divided by 1 plus 1 by 2. So I will get 5 by 6 divided by 3 by 2. Okay, so if we look at this carefully, what we get? 5 by 9. What we get? 5 by 9. This is the x coordinate of center of mass. Okay, 5 by 9, 0. This means the position of center of mass will be somewhere here, 5 by 9. Okay, which is somewhere here. Position of center of mass will be okay. Sorry. Position of center of mass will be somewhere here. Okay, after the midpoint. Okay, somewhere here. So we had find what should be the position of center of mass. Okay. Okay. So see you in next lecture. Thank you.